Alhamdulillah, assalatu wassalamu ala rasulillah. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to derive an expression for kinetic energy and work theorem or work energy theorem. What work energy theorem says is that if something is moving with some velocity, say u, then if we apply a force and this force is in the direction of motion, assume that, then obviously its speed or velocity will increase. Its velocity will increase. When we apply a force, its velocity will increase. So initial kinetic energy was some less, and when force is applied, its velocity increases, therefore its kinetic energy increases. It means by applying a force, we are working on that object, and that work is related to the change in kinetic energy. And how these two quantities are related, we want to see that, we want to observe or analyze that. Come to our whiteboard and let us discuss this. Suppose an object of mass m is moving with an initial velocity u, and when a force F is applied, what happens? This object m starts to move with velocity v, that is, its velocity increases. Obviously we are assuming that v is greater than u, and in doing so, say this force has acted for some time, and during the application of force, it has moved a distance or displacement s. So initially kinetic energy was half m u square. This is the general formula of kinetic energy. We know half mv square, but here our initial velocity is u, therefore we can write kinetic energy half mu square. This is initial kinetic energy, and after some time its kinetic energy changes to k2, and that will be half mv square, final velocity. What is the change in kinetic energy? Change in kinetic energy del k, final kinetic energy k2 minus initial kinetic energy k1, and this reduced to half mv square minus half mu square. We know half and m is common, so we can factor it out, and we are left with v square minus u square. Now we have another thing. We know v square equals u square plus 2as. It is one of the equation of motion, and in this we know this is final velocity, this u is initial velocity, a is the acceleration, and s is the distance or displacement traveled by the body. Now we can have v square, and if we take this u to this side, we have v square minus u square equal to 2as. So we are going to use this formula or this expression here. So we can put v square minus u square equal to 2as, and now our expression becomes del k, that is change in kinetic energy, equals half m v square minus u square, and v square minus u square equals 2as. So this 2 gets cancelled, and now we are left with m a s. We know m into a is acceleration, m is the mass of the object, and mass times acceleration gives us force, and s is the displacement, f into s. Force into displacement. What is this? Force into displacements, and we know force and displacement are in the same direction, and it gives us work done on the body. and this can be written as W. Therefore, we find that change in kinetic energy is equal to work done on the body by the force. This is the main statement of work energy theorem. So, what is work energy theorem? Work energy theorem says that if a force is applied to a body, then some work is done, and this work is equal to change in kinetic energy. That is, the change in kinetic energy of a body is equal to the work done on the body by a force F. So, this is work energy theorem.